We're going to talk about solving three variable systems by elimination. So this is the entry you need to make in your table of contents as well as the title of your next empty page of notes. Solving by elimination. So here are the general steps. I'm going to read through these. Feel free to pause the video to paraphrase these and write these down. So step one is, first of all, decide which variable you want to eliminate. You can get rid of the x, the y, or the z. You just have to make sure you are consistent with which variable you want to eliminate. Step two is, once you figure out what you want to eliminate it from two equations. And I mean any two. It could be the first two, the last two, maybe it's the first and the third, any two equations. Step three, eliminate the same variable from one equation already used in step two and from the last unused equation. Step four is we're going to use the results from step two and three to make a new system. This will only have two variables in it, which is what we want. Then we're going to solve this two variable system for both of the leftover variables. Step five, substitute those values into an original equation to solve for the third. And as always, write your answer as an ordered triple. So our first example for elimination. So we have example 1. We are going to solve 4x plus 3y minus 2z equals negative 4. Negative 4x plus 2y minus 5z equaling 10. And then we have x plus 2y plus z equaling 7. So this is our system we need to solve for the values of x, y, and z. So first step is we need to figure out what are we going to eliminate. So remember that to eliminate, you need the same coefficient, just opposite signs, like a 2 and a negative 2, a 4 and a negative 4. So if we look at our x's, I see I have a 4 and a negative 4, so those are going to eliminate. But then I have just a plain old x. Well, luckily, plain x's are really easy to make any number you want because there's a 1 in front of here. On the y's, I have a 3, a 2, and a 2. So the 2's would be easy, but trying to make a 2 into a 3 is not the easiest thing to do. And the z's, I have a negative 2, a negative 5, and a 1. Those are all different, so I would not try to eliminate the z's. Okay, so I'm actually going to eliminate the x's. I'm going to go for that. So I want to eliminate x. And you do not have to write this step. Normally, this step is just for our notes. So the second step is, okay, well, now that I know what I want to eliminate, let's pick some equations to eliminate it from. So we have the first equation, the second equation, and the third equation. First, second, third. I'm going to take the first two because those are going to eliminate already. So I'm going to use the first equation, 4x plus 3y minus 2z equals negative 4. And the second equation, negative 4x plus 2y minus 5z equaling 10. I chose these because these x values will already add to 0. I don't have to do anything to these equations. So we're going to add these together. So 4x and negative 4x will make a 0x. 3y and 2y will make a 5y. And then negative 2z and negative 5z will make negative 7z. Negative 4 plus 10 makes positive 6. So we're going to hang on to this guy until later. Step 3 says, I'll do step 3 here. Step 3 says, now I need to take one of the equations I already used and the last unused one to eliminate the same variable. So we're still going to want to eliminate x's. Now, I'm actually going to pick the second equation that I already used and the last one that I haven't used yet. And the reason for this is a negative and a positive. So I'm already halfway to what I need to eliminate. So here's the second equation that I already used. Negative 4x plus 2y minus 5z equals 10. And this is the third equation that I haven't used yet. So this is that unused equation. Okay. Now, unfortunately, to eliminate these, I'm going to have to manipulate this bottom equation. I need a negative 4 and a positive 4. So I need to multiply this whole bottom equation by a 4. So let's see what that turns into. I'm going to do it to the right. That's why I put an arrow. So let's see. The top equation is not changing. So negative 4x plus 2y minus 5z equals 10. That didn't change. But the bottom equation, 4 times x makes 4x. 4 times 2y makes 8y. 4 times z makes positive 4z. And then equals 7 times 4 makes 28. Now, when I add these up, now my x's are going to eliminate. Negative 4 and 4 add up to 0. 8 plus 2y makes 10y. Negative 5z plus 4z makes a negative z. And 10 plus 28 makes 38. So we're going to hang on to this one as well. Okay, so now we are on to step 4. So step 4 says take the results from step 2 and step 3. So here's step 4. I'm going to take this result here and this result here and make our own system from it. So my red equation from step 2 is 5y minus 7z equals 6. And the equation from step 3 was purple. 10y minus z equals 38. And we need to solve this system by either substitution or elimination. I think elimination is going to be a little bit easier, and I'm going to choose to eliminate the y's because I don't want to multiply a 38 by a 7 because that's going to be crazy big. So instead, I'm going to multiply the entire top equation by a negative 2 in order to make the y coefficient a negative 10. So let's do that over here to the right. So negative 2 times 5y makes negative 10y. Negative 2 times negative 7z is a positive 14z equals 6 times negative 2 makes negative 12. And the bottom equation, we're not changing. 10y minus z equals 38. Now that we're ready to cancel the y's, we'll add these up. The y's make 0. 14z minus a z makes 13z equals negative 12 plus 38 makes 26. And to get z by itself, we're going to divide by 13, and we end up with the solution that z is equal to a 2. Now, that's one solution. We need 2 more. So let's find the first one by using our 2-variable system because we're still in step 4. So I think it's easier to substitute into the bottom equation. Looks a little less difficult. So it's going to be 10y minus z, which is actually a 2, equals 38. Now, since there's just a negative 2, we're going to add 2 to both sides. So we end up with 10y equals 40. Divide by 10, and that gives us that y is equal to 4. So there's our second piece. So that's all step 4. This is solving that 2-variable system. Now that I've solved the 2-variable system, we have 2 of our pieces. So step 5 is taking those 2 pieces, substituting it into an original equation to get our third piece, which in this case is our x. So if we look at our equations, the third equation, x plus 2y plus z equals 7, looks the simplest to use. So we have x plus 2 times y, which is really a 4, plus z, which is a 2, is equal to 7. And we're going to solve this guy for x. So we have x plus 8 plus 2 equals 7. 8 plus 2 makes 10. Subtract the 10 from both sides. And we end up with x is equal to negative 3. There's our third piece. So our step 6, our final step, is to write this in our ordered triple as an answer. So it's always the x, then the y, and then the z. So our solution here is negative 3, 4, 2. Let's look at another example. And then you guys are going to try one on your own. So example 2. We have x minus 2y plus 3z equals 9. Negative x plus 3y equals negative 4. And we have negative 5y minus 14z is equal to negative 23. So if you notice on this one, we're missing a few things. There are some equations that are already missing variables. So you can use that to help inform your decision on what to eliminate. So if we look at the first equation, the first one has all three variables. That's not helpful. So we need to figure out, let's look at the other two. Then we have negative x plus 3y. Well, that's missing z. And on the bottom equation, we have a y and a z, but no x. So it would be beneficial either to eliminate z's or to eliminate x's. But I'm actually going to eliminate the x's because one's positive and one's negative, and these are ready to go to eliminate. So I want to choose to eliminate the x's. So step 2, let's actually go and eliminate from the top two equations. We have x minus 2y plus 3z equals 9. Negative x plus 3y. Now I don't have a z, so I'm going to put plus 0z because there are no z's. So I'll put a 0 as a placeholder. These are ready to eliminate, so we can add these together. X and negative x will add to a 0. Negative 2y plus 3y makes a y. 3z plus 0z makes 3z. And 9 minus 4 makes 5. Now, step 3 is you're supposed to eliminate from the last unused equation and one of the ones you used in step 2. But if we look at that last unused equation, we eliminated x, but there's no x here already. So step 3 is actually done for us. There is no x here. So what we can do is we can move on to step 4, which is make a new system. So step 4 is going to use the result from step 2, that y plus 3z equals 5. And it's going to use technically the result from step 3, but I didn't need to do step 3 because my original equation is already only in y's and z's. So this one was actually already ready to go. So now we need to solve this system here. So let's see. It looks like y will be easier to eliminate because 3 and 14 are not common multiples very easily. I can make a 1 into almost anything though. So I'm going to multiply the top equation by a 5 in order to eliminate my y's. So 5 times y makes 5y. 5 times 3z makes 15z. And 5 times 5 makes 25. And our bottom equation did not change, so negative 5y minus 14z equals negative 23. Now we're ready to add these together. 5y and negative y will make a 0. So 15z minus 14z makes 1z. And 25 minus 23 makes 2. So there's our one variable already. Let's sub it back into one of these equations in step 4 to find our y value. So I'm going to use the red one. Y plus 3z, but I know z is really a 2, equaling 5. So this z went here. Y plus 6 equals 5, and if I subtract 6 from both sides, I end up with y equals negative 1. Almost there. Now, let's look at the original equations because that's what step 5 is. Step 5 is substitute our known variables into the original equation to find the last one. So if I look at my originals, this top equation uses x, y, and z. The second one uses only x and y, but the third one doesn't even have an x. So I can't use this third one because the x is the unknown right now. So I need to use one of these two. The second one is actually simpler because all I need is y. That's it. I don't even need the z. So I have negative x plus 3 times y, which is a negative 1, equaling negative 4. So negative x minus 3 equals negative 4. Add 3 to both sides. Negative x equals negative 1. And then we divide out the negative 1 to find that x is equal to 1. So our step 6 is write the ordered triple, which is 1, comma negative 1, comma 2. Not every problem requires every step. Let's look at example 3. So you guys are going to try this example 3 on your own. So example 3 is x plus y plus z equals 2. X plus 3y plus 2z equals 15. And we have 4x plus y minus 3z is equal to a negative 6. And the solution you should end up with at the end is negative 4 for x, 7 for y, and negative 1 for z. So try out example 3 using the steps listed above and see if you can't get this solution.